All right. So the first thing I'm going to show is something I did a few weeks ago at I believe, our first learning group session. And one of my friends had the question. This has to do with the reverse name pipe feature within Metasploit. And I believe the way this was originally implemented was that if you have a Meterpreter beacon on one of your Windows target, and then with that Meterpreter beacon, you would then use, Meterpreter shell or agent, you would then use that as a pivot to use this SMB name beacon feature, SMB name pipe feature. And one of my friends asked, can you run this directly, the name pipe callback on your Kali box, to sort of get the callback and then run the payload on the target, and then can it talk directly to Metasploit running on Kali, right? So that was a question. So, and I was curious, according to what I know of the code, I believe that that's not the case. But the best way to verify is to actually try it out yourself, right? So the payload I created here is this one right here. So basically, reverse name pipe. The pipe host is this IP address of this calling machine, and the pipe name is this MSF-pipe, right? So the name of the file is kpipe. And let's go here to Meterpreter, and we show the options here.
Real quick, could you go back to that previous tab? You had some MS Venom in there.
Yes.
So what are you doing here with this shell code? I see that you're sending some things to buffer registers and things like that.
Yeah. So
briefly.
Very briefly. So this stuff has nothing to do with this particular demo, but you're a curious cat. But so I can tell you, I think I was messing around with this other machine, and it's an exploit to a specific vulnerable server. And so the -b is bad character. So the application, right? If you send any of these characters, it will stop your data stream to it, your network connection to it, right? So you have to specify these bad characters to MS Venom so it doesn't use it in its generation of its shell code. So that's what it means in a nutshell. This buffer register, this is really quite interesting if you get more into how those buffer exploitation actually works and what you need to specify in your shell code, right? So I think the way it usually works by default with MS Venom when it creates its payload is that it has special staging code to figure out where your shellcode starts in memory, right? So it has that specialty. But some due to size restriction in terms of how much space you have to send your payload, that's number one. Excuse me. And possibly because of bad characters limitations, that default mechanisms won't work. So instead, you can specify if at the point of your crash or where you take over the instruction pointer of the CPU and you're doing a lot of assembly, so some of this stuff will like click for you, right? If there is a register that is pointing to your payload, you can specify here with this buffer registered argument, right? And that way the generated shellcode will use the offset here. It says, okay, shellcode is in ESP, so I can use math as just like, okay, I use that offset for generating the shellcode. So that's what all this mess is in the nutshell. Okay. And I imagine you're curious because you're doing a lot of assembly code stuff right now. So that's really cool.
Right. I see some reference there for the buffer register. ESP usually means like the start of a stack pointer. I saw it in your terminal and I was like, is this related? So, okay.
Not for this demo, but potentially for future ones. Yeah. For this one, it's this payload is reverse name pipe. The pipe host is the IP address of this calling machine. And very important, the pipe name is the default one, MFS-pipe, right? And then we go back to our callback here, right? Everything is configured as it is. But one interesting thing I would say, okay, so I guess I could change my pipe host, right? So let's change the pipe host to this IP address. And I'm curious, will that make any difference? 146 options, and then now we run. So now the callback handler is running here. Let me jump to my Windows. So here I have my Windows box, and this is the payload that I moved here previously. So, okay, one other thing. So now I'm going to show you some steps that you can use to sort of troubleshoot. And for competitions, this is really good. And just for just general troubleshooting, this is really good to sort of have some of these tools. So I have Wireshark running on a Kali box so we can see all the traffic going back and forth from the machines, right? So here, I'm gonna run kpipe and I ran it, right? And if you look at my background for my Kali box down here, there's no callbacks, nothing happened, right? And if you jump to Wireshark, okay, let me stop it right here. So this named pipe, it's going to call back on port 445. That's the pipe, the SMB port, right? 445. And what we're seeing here is you're seeing a bunch of reset packets. So the victim is trying to send to me, and then me, Kalibox, is sending back reset. So what that means usually is that I don't have a port open running on my machine. So right here, if I jump to my Kalibox again and run netsat, check it out. There is no 445. So this goes to show that so you know what happened here, right? I had a friend ask me a question about, okay, how does this thing work? Can I run it directly with Kali to connect back with Kali? And I'm curious what the answer to that too, right? And if you weren't to look at the code, or you didn't have the skills to analyze the code, then you could try this kind of process of going through it and figuring out, wait a minute, I ran it. Number one, it didn't open any ports on the Kali box. And then I ran the payload and there was no connection back. So that just goes to show that this particular payload, the way it was implemented, I believe I would have to do more source code analysis to verify it 100%. But according to what I've seen so far in my testing, it shows that this is only implemented with the pivot mechanism if you already have an interpreter shell on your target. So that concludes this specific demo. The next one I want to show, this one I sort of am a little excited about, even though to some more advanced people, they might think it's not that very interesting. But okay, yeah. So now I'm going to demo how to get a PowerShell. So yeah, how to get a PowerShell callback, right? So let's go through the different steps here. First is creating the payload. That's step number one. So let's check my Venom, right? So in this case, check it out. I use this command to create my binary payload, right? So what it is, it's a Windows shell reverse TCP, and the port here is 444, exe for Windows, and then the name of it, which is mshell 444, right? So pretty simple. But then question for those who are like going through their OSCP or don't have that much experience with Metasploit. So if I do this, what application can I use to catch this shell on my Kali box?
So I would think you would need to use Meterpreter to catch the shell.
I would use Metasploit, yes. So I can definitely use Metasploit.
Oh, Metasploit. Yeah. But you would need to set a specific handler in order to catch the shell.
Exactly. And so I can sort of show that really quick right here, right? So you're spot on. So the handler you would use would be use exploit multi-handler. That would be the one. And then you would set the payload to the exact same thing that you specified within your NS Venom. So set payload, Windows, shell, reverse TCP, right? And then you have your options here. And everything is already set up. So I can just run it. And let's go to our target here. And let's see here. So that's mshell. Run it, and then we get a string here saying that it came back, and yeah, right. So you can catch it with you can catch it with a Metasploit, right? So let me just exit this. But then this is something that's very important to keep in mind. So you can catch it with Metasploit, but because of this type of payload we're using, you can also catch it with netcat as well. So, and the payload here is Windows /shell _ reverse TCP. So this is further research for those who are interested. This is called a non-stage payload. The way it's specified, there is also a stage version of it. So with the stageless version, I can use netcat with this specific one. If you're using anything Meterpreter, you will not be able to use netcat to catch it. So, these are very important points that you will learn if you sort of go through that trial and error process of playing with this type of stuff. So right now, instead of using Metasploit, I'm using netcat, right? So let's go over here again, mshell, boom. right? We get our callback, netcat caught it, right? So now this is super duper important for people who don't have much experience with this, right? So if I run commands such as, say, like, version to get the system version, right? It outputs semi-fine. If I run the type command, it outputs semi-fine. But the question is, if I run a command such as FTP or PowerShell, what will happen? What do you think?
I don't think it's going to work. I don't think that you have a path to that binary set in the shell that you've caught.
So that's sort of a good hunch, but the problem with FTP and PowerShell, let's look at it if we're on the actual Windows system, right? So say I do FTP, it gives me this FTP, and then I can write help, and so the thing with FTP here, and let's do PowerShell as well. So once I hit PowerShell, okay, things come back, and then we get something different, right? The thing with FTP and PowerShell is that these are interactive applications. So they're interacting with the actual console. When I run commands such as type or netstat, all of that is just one direction, right? It's just outputting the output to my shell. But commands such as FTP and PowerShell, they interact. So check out my shell here, right? So right here, I'm in my netcat shell. I run FTP, nothing comes back. It just hangs, right? And because the default netcat shell does not have interactive capabilities. That's the problem that we're running into, right? And just to show the other case really quick as well here, exit m shell, yeah. So again, I get my shell here, dir, right? It works fine. I run PowerShell. Okay, I get a little bit of output here, right? But if I do get host, nothing comes back. Again, right? Non-interactive. It just hangs, right? That's a problem. So we have a problem, right? We have a problem with having interactive PowerShell. So now we have to come up with a solution to that problem. So let's set up our initial condition once again here. Okay, we're here, we're there. Okay, awesome. Okay, there's a lot of steps here. So the way to get around that is that I have this PowerShell script right here. It's called invoke PowerShell, right? And just to scroll through the code real quick, right? So what this invoke PowerShell does is it uses PowerShell commands to create a TCP connection, and then it handles all of the streaming. That's what it does, right? So right here, you see the stream right, and then it has a while loop to read from the stream. So basically, it implements the streaming, the interactiveness, going back and forth. That's what this PowerShell script works. This is how the PowerShell script works. And the function of this scriptlet is called invoke PowerShell. And in order to get it to execute, at the very bottom of your PowerShell script, you would call the function of that scriptlet, which is invoke PowerShell, and then you would give arguments. In this case, the argument is make it a reverse TCP, give it the IP address, and then the port number. So this is what you have to put in this PowerShell to get it to work, right? So there's the PowerShell. So this PowerShell is on my Kali box. So I need it to make it available to the actual target. So what I'm going to do, because I'm a dirty old school Python 2.7, heathen, right? I use HTTP server 8080. Okay, so oops, let me fix the typos here because we like capital cases. Okay, so now now I have a Python web server running on my Kali box. That's going to serve that PowerShell script on port 8080. So that's number one. So I have a PowerShell. The other thing is that if we remember from our invoke PowerShell, right? It's going to call back to our Kali box on port 55555. So now I have to create a netcat listener here on port 55555. So see, a lot of steps, right? And then, okay, I have the web server that's going to serve the PowerScript. I have a callback, a catcher here, a listener here, that's going to catch when this invoke PowerShell script is run. And then finally, right, in my original command prompt, just regular command prompt, I need to execute a command that will pull down that PowerShell script from my server. That's the final step here, right? So check it out, right? So this is the syntax here, right? IEX new object, new web client, and download. So this download string will download, and the argument I give it is IP address and the port of my Python web server 8080, and then the name of that particular script. This is what this is. So let's sort of think about it, and let's sort of try to figure out the timing of what will happen. So when I first run this command, where am I going to see activity first from these two consoles here?
Well, so you're asking it to grab a resource that's being hosted on the 8080 that's being served by the Python. So the Python's going to start showing you GET requests.
Yes.
To your simple web server.
Spot on. Exactly. Yeah, that's exactly right. So yeah, and that's the kind of logic that you have to do when you run these sort of very complex activities that includes multiple components. And you're exactly right. So the first is pulling down the resource, and then it will execute the resource. So after that, then we should see a connection here, right?
And
so
the new shell come back.
Yeah. Exactly. So again, right, from my original shell that I wanted PowerShell from, I run this command to download my resource. I run it. Then I go to this guy right here, my Python web server, and I wait, twiddle my thumbs for a little bit. And yes, whoo,
cool.
Right? So you get the GET request. And then finally, you jump to your third window. And lo and behold, right? You get your PowerShell. So, dir get host, right? I get some really cool stuff here. So I can execute some of these PowerShell commands. So very awesome, right? Now I have PowerShell if I need to use some of the PowerShell functionality. But one of the problems I ran into here that is a problem on my particular environment, if I were to run a command such as write host, say hello Dave, right? If I were to run this, unfortunately, I think that's sort of interactive. And according to the way, for whatever reason, I haven't troubleshoot this yet. It's sort of just hanging here, and I don't know the specifics why. But another data set though is that I ran this on another VM on another environment, and I had weird activity where if I press return a couple of times, it looks like the buffer flush, and then I saw it in my other window. So my original CMD window, I would see it, and then it would finally show here. So it was some weird buffering issue, I believe. But I think for my own lab environment, for whatever reason, this does not work. So that kind of like upset me. But again, it just goes to show when you're doing these kind of pen testing, red teaming stuff, there's so many like gotchas, and there's so many different factors that could really muck with the results. So that's just something to keep in mind. And with that, I'm finished with my demo.
Real quick, Candy.
Yeah.
Just throwing back to something that I think Craig was showing us.
Yeah.
So Craig used a different way to import something off of a Python web server. He was using certutil.
Yes.
URL cache flag.
Yes.
So in your I think it's your second terminal over there. You were using a specific PowerShell invoke to grab the string. Is that because certutil is also an interactive program, so we wouldn't be able to use it?
That's a really good question. It's for your question, it's just a matter of preference. So but again, you're spot on in terms of you're thinking about what the actual goal is, right? The goal is to be able to download a resource that you need to execute. And in Craig's example, he used certutil, really good application to be able to do that. That's all good and fine. For me, I just use PowerShell. And I think in my particular case, I think the additional advantage I have is that it executes it right away in terms of the argument I gave. If Craig were to use the certutil, he would have to combine it with another PowerShell command. So he would use the certutil, and then he would use another PowerShell command to actually execute the script, right? But both ways work. There's nothing wrong with his way or my way. Both way works.
But now thinking about it, if I'm under the gun as a red teamer, right?
Yeah.
Because I'm fighting against either an automated system detecting me or the skill level of my blue teamer finding me. So it might be more beneficial to research something like what you're showing with that PowerShell execution, where it's grab it and then execute it, grab it and then execute it, chain as many of these commands together as possible. Is kind of what I'm taking away from it, because the faster your execution rate to get to exploit is more efficient than running through steps that you know are tried and true.
So that is a really good point, and it is correct for a lot of use cases. For instance, later we'll talk about your CCD experience, and I imagine for CCD that is the right approach. And okay, so you're spot on. And for me though, there are some other situations, some other factors to consider. For number one is that Craig's way of using cert utils, you will download something to disk. So that's number one. And depending on the situation, that could be okay, right? Nothing wrong with that. In my case, when I use this download string, it goes directly into memory. So check out. So, you know, I already ran that and that execute properly, but look, there's no ps.1 file here.
Interesting.
Right? So that's another factor. And I forgot, but because of your line of questioning, I was able to share that, right? So that's number one. So now let's go back to your question about being efficient and being fast, right? So I would push, I would add some caveats there in terms of if you're trying to emulate a more advanced adversary, I agree with you totally. So advanced adversaries would do exactly what you're saying, being very efficient, right? Doing it as quickly as possible, leave as few artifacts as possible. That is completely true. But I would caveat that in terms of in learning environments, which I feel like, for instance, the CyberForce competition, depending on the skill level, it makes a lot of sense to do the more less skilled, less fast way. So the blue teams get to learn that. Right, so they, hey, a red team or an adversary can do the more cert util and then run a PowerShell. That is a legitimate execution flow for a red teamer. So you should be able to aware of that. But then for our purposes, perhaps you should be aware of this advanced too, so you can do both. And in the CyberForce competition, how we set up, we have that opportunity, right? But in other competitions, I believe, like for instance, the CCDC, you don't, because you have to get your shells right away, right? So that's a little different. So again, it depends on the situation, right? And you know, depending on the goal. But yeah, really good questions.
Awesome.
Cool.
Well, this was fantastic, Candy.
Thanks. Okay, let's see here.